Welcome dear students, we are on the CEC Gurukul lecture and we are in the series of electronic circuit, and we are discussing the digital electronic circuit. And the digital electronic circuit we are discussing the logic gates. Up to now we have discussed the many logic gates. In this series we further move, like we discuss the XNOR gate conversion. Now we convert the XNOR gate. The XNOR gate can be formed by using the XOR gate and the NOT gate. That is why it is a XNOR gate. And the Boolean expression of the truth table will be shown here. In this logic gate, when the output is high 1, then both the input will be either 0 or 1. Then we can get the high output. Like here we are having the XOR gate plus a inverted NOT gate. So XOR plus NOT will make it as a XNOR gate. So we can get the XNOR gate here. Now you see the truth table here. This is the symbol in the above figure. You are seeing the symbol XNOR plus NOT, and below here it is the XNOR gate symbol. So like Y is equal to A invert B plus A B invert. After that we take the invert of that, because we are taking the NOT gate here, or we can represent as a bullet here. So you see, A is, if input is 0, input is 0, A input is 0, B input is 0, then the output of 1 we will get, high output we will get. Means the both the similar input, then the high output we will get here. If it is dissimilar, then the low output we will get. That is why 0 0 1 1 we are having a high output, that is 1 1. If 0 1 1 0, then we are having the low output, that is 0 0. Now logic family we will discuss. Behind this logic gate, what circuit design we will use, what component we use, what electronic component use to design this logic gate. Basically what we use again the transistor, resistor and the diode we use for construction of that. The type of logic devices are classified into the families, like of which the most important are the TTL and the CMOS. These are the main families. What is the TTL? TTL is the transistor logic made of bipolar transistor. Means when we construct the logic gates we use the transistor. So that family is known as the TTL, means transistor logic we will use. And another is the CMOS. CMOS means complementary metal oxide semiconductors made from MOSFETs that we will use. ECL, emitter coupled logic, for extremely high speed we will use. Next is NMOS, PMOS, for VLSI, large scale integrated circuit we use for the construction of that. So what is the TTL and how it used? So the transistor logic TTL family was developed in the use of the transistor switches for the logical operation and define the binary value, that is 0 volt to the 0.8 volt, which is the logic 0, 2 volt to the 5 volt, which is the logic 1 TTL is the largest family of the digital ICs. But the CMOS family is growing rapidly nowadays and they are inexpensive, and but draw of the lot of the power and must be supplied with a plus 5 volt. Individual gates may be drawn 3 to 4 milliampere. The low power Schottky version of TTL chips drawn only 20% of the power but are more expensive, and the part numbers for these chips have the LS in the middle of them. But in place of the CMOS logic family, the complementary metal oxide semiconductor family has equivalent to the most of the TTL chips. There is a series of the chips here that we will define further. Then CMOS chips are much lower in the power requirement drawing about 1 milliampere and operating with a wide range of the supply voltage from 3 to 18 volts. So CMOS models number and have the C in the middle, and through represent whenever we are having the C, then it is the CMOS. So any CMOS model number have the C in the middle of the number. Like you see here 74C04 is the CMOS equivalent to the TTL 7404. So this is the difference between the transistor logic and the CMOS logic. In the CMOS logic, the number represented by the 74C04, but here it is 7404. A high drawback is extremely sensitive to the static electricity. They must be carefully protected from the static discharge. And apart from this, NMOS and PMOS logic ICs, NMOS means N channel metal oxide semiconductor, PMOS means P channel metal oxide semiconductors. After the advantages of the high component density than the TTL chips, there are not nearly so many TTL equivalent CMOS. They are sensitive to damage from the electric discharges. The component designation like that, integrated circuit in the TTL logic family have part number which 4 to 5 digital number, and with the introduction of these construction of the devices, letters are added to the center of the numbers and remind the user that basic TTL chips are not being used. So device number is given to the chip. The device number begin with a prefix which tells about its series, followed by another number which identifies the individual devices. Like 7400, the TTL designated as 74C00, the CMOS equivalent to, and 74LS00, the low power Schottky implementation. And in this manner, a device can be designated or a device is named. If it is simple TTL, then the number. If it is having the CMOS, then the C is introduced in it. If it is a Schottky implementation, then the low power Schottky implementation, then LS will be in between that. So this is the in the standard transistor. Transistor logic IC, there is the predefined voltage range for the output and output voltage level, and which define the exactly what is the logic 0 level or what is the logic 0 level, and these are shown below. Now you see that TTL input and output voltage level. You see there is a range of the layer. You can be seen in the diagram that how this range can be defined as the input is given and the output we will have. This is basically the AND gate output. Logic gate, logic we will apply here. After applying the logic, this depletion layer will be increased. So there are the large variety of the logic gate and types of both bipolar 7400 and CMOS 4000 families of the digital logic gates. You see here 74LXX and 74LSXS, 74ALSXS we have put with the 0 value, 74HCXX high, and next is 74HCTXX, 74CTXX, etc., and each one having its own distinct advantages and disadvantages compared to the others. So exact switching voltage required to produce either the 0 or the 1. It depends upon the specific logic group or the family. However, when using a standard plus 5 volt supply, any TTL voltage input between the 2 volt to the 5 volt and is considered to be the logic high 1. While any voltage input, if it is 0.8, then it is recognized as a 0 and we can say it is a low. Now this range you can remember that 0 to 5, it is considered as a logic 1. If it is 0.8 or below the 2, then we can take it as a low. So the voltage range, so the voltage region in between the two voltage level, either as the input or as the output, is called the indeterminate region. and the operating within this region may cause the logic gate to produce a false output. So, in this indeterminate reason we can get the operation of the logic gate, otherwise we will get the false output. So, CMOS 4000 logic family uses the different levels of the voltage compared to the TTL types. They are designed using the field effect transistor FETs. In the CMOS technology, logic 1 operates between the 3 to 18 volt, 3.0 to the 18 volt, and the logic 0 below the 1.5 volt. And again repeat this line that the CMOS technology, a logic 1 level operates between the 3 to 18 volt and the logic 0 level in between the 1.5 below. And then the following tables are shown, different types of the logic gates, traditional TTL and the logic gates, CMOS logic gate. You see this table you must know. Like then from the above observation it can be defined that the TTL digital logic gates, one that of the low level 0 and one of the high level 1, and this is the range. You can see device TTL logic 0 from 0 to 0.8 volt, logic 1 from 2 to 5 volt, that is VCC, and CMOS 0.0 to 1.5 volt to 3.0 to 18 volt, that is the VDD. So, you see the simple circuit and the simple output here, ideal TTL digital logic gate volt level you see here. Then we define the register input and output. We define the logic gate is switch is open and switch is closed. So, this will give the desired output, where the opening and the closing of the switch is produce either the logic 1 or the logic 0, with the resistor R being known as the pull up resistor. So, now the digital logic noise, there is a noise in the circuit, and then however between these defined low and high values lies what is generally called the no man's land and the blue area above, and if we apply a signal voltage or the value within no man land area, we do not know whether the logic gate respond its level 0 or level 1, the output will become unpredictable. So, it means a noise is the name given to the random or the unwanted voltage that is introduced into the electronic circuit. So, by external interference such as the nearby switches, power supply fluctuations from the wire, from the other conductors that pick up stray of the electromagnetic radiation. So, then in order for the logic gate not to be influenced by the noise, must have to certain amount of the noise margin or noise immunity. So, you see here in the diagram that this is the noise we are having in the XOR gate. So, this noise is produced. So, how we will tackle this noise? In the example, this noise signal is superimposed onto the VCC supply, voltage supply, and as long as it stay above the minimum level, that is the V on minimum, the output is corresponding to the output of the logic gate are unaffected. But when the noise level become large enough and a noise spike causes the high voltage level to drop below this minimum level, the logic gate may interrupt this spike as a low level input and switch the output accordingly, producing a false output switch. And then in the order for the logic gate not to be affected by the noise, it must be able to tolerate the certain amount of the unwanted noise on its input without changing the state of its output. So, that noise can be removed if it is not disturbed, and if it is disturbed, that the logic gate not too affected by the noise, it must be able to tolerate a certain amount of the unwanted noise on its input without changing the state of its output. What is the simple basic digital logic gate? In the simple digital logic gate can be made by combining the transistor diodes and resistor with a simple example of the diode resistor logic, that is the DRL, or the gate and AND gate and a diode transistor logic NAND gate, that we will discuss. Diode digital, diode resistor logic gate, as well as we are having a diode transistor logic gate, means we can construct a transistor by using the combination of the transistor, diode and the resistors. So how we will construct it? You see in the diagram that here we are having the two diodes and one resistor, and that will give the two inputs we are giving through the diode, and the one output we are taking by varying the resistance. So this is basically the logic diagram. This is the electronic diagram. So that represent the two input. Here the two diodes is defined, then battery is attached here, the resistance we are having, then we can get the output. So output we will get in the form of the, now again this is similarly we can use it by using the transistor. Two input through the diode, then it will go into the transistor. After the transistor we take one ground and one output we will get. The resistance where can be varied. So the simple two input diode resistors AND gate can be converted into the NAND gate by the addition of the single transistor, that is the inverted NOT, that is NOT, and using the discrete components such as a diode, resistor and transistor to make the digital logic gates. Circuits are not used in the practical commercially available logic ICs, and as these circuits suffers from the propagation delay, so or gate delay, and also the power loss due to the pull up resistors. Another disadvantage of the diode resistor logic is that there is a no fan out facility, which is the ability of a single output to drive many input of the next stage. So also this type of design does not turn fully off, as a logic 0 produces an output voltage to the 0.6 volt diode voltage drop. So the following TTL and CMOS circuit design and use instantly. What is the basic TTL logic gates? In the TTL where we use the transistor, the simple diode resistor AND gate above use the separate diodes for this input and one for each input. But as a bipolar transistor is effectively two diode junctions connected together, representing either an NPN or the PNP devices, means positive negative positive or the negative positive negative transistors we will use. So the input diode of the diode transistor logic, that is DTL circuit, can be replaced by one single NPN transistor. So with multiple emitter input to form another type of the logic circuit called the transistor logic or the TTL. You see here we are having this type of simplified, this is a simplified NAND gate circuit which consisting of the two input transistors TR, and which TR1 has two input and two or more emitter terminals and a single stage inverted NPN. We can take switch the transistor circuit to the TR2. This one is attached with the another. Now you see here that this input is one transistor output is attached with the another output. Now when either or both of the emitter of the TR1 representing input A and B and are connecting to the logic 0 low, then the base current of the TR1 passes through its base emitter junction to the ground, that is a 0 volt TR1, then saturates and its collector terminal which follows with this action result in the base of the TR2. Now this TR2 becoming connected to the ground 0 volt and TR2 is off, the output Q will be the high. So when both the input A and B is high, the logic level will be the high. Input transistor TR1 turns off, the base of the switch transistor TR2 becomes high and the turns it on, and so the output at Q is low due to the switching action of the transistor. The multiple emitters of the TR1 are connected as input, thus producing a NAND gate function. Next is the emitter coupled digital logic gate. In the emitter coupled logic gate, that is a ECL, is another type of the digital logic gate that uses the bipolar transistors logic, where the transistors are not operated in the saturation region as they are with the standard TTL digital logic gate. Instead of the input and output circuits, and are the push-pull connected transistors with the supply voltage negative with respect to the ground. So this has the effect of increasing the speed of the operation of the emitter coupled logic gates up to the gigahertz range, and compared with the standard TTL type, that is ECL, logic becomes a unsaturated transistor, operates within their active region and amplified as well as switch signals. So these are the ECL family. Now we are saying that we use the integrated circuit as a logic gate. So 4 sub families we use for the integrated circuit. So with the improvement in the circuit design to take account the propagation delay, current consumption, fan in, fan out requirement, etc. So this type of TTL bipolar transistor technology forms the basis of the prefix 74, and this 74 family of the digital logic ICs such as 7400 quad 2 input AND gate and 7402 quad 2 input NOR gate. So in this manner we can have this family. Some families of the 74XX series ICs are available related to the different technology used to fabricate the gates, and they are denoted by the letter in between the 74 designated and the device number. So they are the number of the TTL subfamilies available that provides a wide range of the switching speeds and the power consumption, such as we are having a 74L00 or the 74ALS00 AND gate, for the L standard the low power TTL, and the ALS stands for the advanced low power Schottky TTL. So these are the listed below. We will discuss one by one. That is the 74XX, or we can say it is a 74NXS. Like standard TTL, this is a standard TTL. These devices are original TTL family of the logic gates introduced in early 70s, and they have the propagation delay and a power consumption of about the 10 milliwatt. So power supply means we are having the TTL family of the logic gates introduced in the early 70s, and they have a propagation delay of about 10 nanosecond and a power consumption of about 10 milliwatt, and supply voltage range 4.75 to the 5.25 volt. 74LXS L for low power TTL. Power consumption was improved over the standard type of the increasing the number of the internal resistance, but at the cost of reduction of the switching speed. Supply voltage range is 4.75 to the 5.25 volt. Another is the 74HXX and high speed TTL, and switching speed was improved by reducing the number of the internal resistances, and this also increases the power consumption like supply voltage from 4.75 to 5.25 volt. And 74SXS, which is the Schottky TTL, and the Schottky technology is used to improve the input impedance, switching speed and the power consumption 2 milliwatt and 2 millivolt and 2 milliwatt, and compared to the 74LXS and moreover 74HXX type. So supplying a voltage range from 4.75 to the 5.25 volts. So 74S LS for the low power Schottky, TTL same as 74SXS, and then types, but increase internal resistance to improve power consumption, supply voltage range 4.75 to the 5.25 volt. 74AS XX advanced Schottky, TTL improved design over the 74S XX Schottky type, optimized to increase the switching speed at the expense of the power consumption. Moreover, 74ALX advanced low power Schottky TTL, 74HCXS, that is the high speed CMOS, 74HCT XX high speed CMOS technology and transistors to reduce the power consumption of the less than 1 microampere. These are the ICs which we can use in the digital circuits. Thank you very much.